All right, I think we're ready to go here now. So, yesterday we discovered through our activity that if we have two triangles that have all three sides congruent to all three sides, that's enough to say that the two triangles are indeed congruent all the way. Okay? So the first thing that we're going to be doing today is, can we identify congruent triangles?
Probably.
I think so. This is usually pretty straightforward. And side, side, side is probably the easiest one to recognize. We did this same thing with side, angle, side, right? Took a look. If we had two triangles in a picture, did we have the side, included angle, and side? Well, three sides and three sides, that's very easy to see. So, like, for example, so let's call it A, B, C, D. Okay. Are those two triangles congruent in that picture? Yes, they are. And can I use side, side to say yes, they are? Absolutely. Because they share that third side, right? So that third side should be the same for both triangles. Put a little tick mark there to show that. So yeah, so then I know those two triangles are definitely congruent. So can we make a congruent statement? Triangle what is congruent to triangle what? And just be careful again that we're matching everything up correctly. Yeah, Zach?
Triangle ABD is congruent to triangle CBD.
Triangle ABD is congruent to CBD. Good. That'll work. Now, it doesn't have to be exactly that same way. You could, as long as it's staying consistent from one or the other. So if you did, like, let's say DBA for the first one, then you'd have to go DBC for the second one, okay? You could do it that way. Or you could do BAD and then triangle BCD. As long as, like I said, as long as you're staying consistent with the order that you do the points in, it's fine. Just everything that corresponds needs to match from one to the other, okay? So, I think we're probably okay with that. Now, there's one other way to prove triangles congruent that's pretty much side, side, side. It's just involving right triangles. And here's the thing about right triangles. You guys have done a ton of this in the past. If you use the Pythagorean theorem on a right triangle, if you know two sides, you can always find the third one, right? Using the Pythagorean theorem. Has to be a right triangle, but that works, right? Okay. So, if I have two triangles that I know are right triangles, and let's say both of them, they don't look the same, but they are. Let's say both of them, I know that this side is 2, and the hypotenuse on both of them is 5. So, do I know those two triangles are congruent? At the moment, it appears as though it's no. Because do I have side, side, side there? Mm-mm. I got side, side, and then I have this angle, right? But if I use the Pythagorean theorem and find this missing side, wouldn't I get the same answer on this one?
Yep.
Right? I don't know what it is, but I could do it. Well, in fact, I think we will in a minute. But I would get the same answer there as I do here. So then, technically, I would have what? Well, okay, that's the answer for that. But I would, like, these two would be congruent using what? Side, side, side. Because I know this has to be the same as this. So those are going to match. These match. Those match. I've got side, side, side. Okay? So, when you have right triangles, you really only need two sides. And you can prove they're congruent. Okay? No matter what. If you have two right triangles, and you know two sides are the same to two sides, that's enough. That's good enough, too. Mm-hmm. Okay. So, but let's work it out real quick here. So it would be like 2 squared plus b squared equals c squared. Oops, be 5 squared, sorry. Because our hypotenuse is 5. Okay, so if I work that out, I'm going to get 4 plus b squared equals 25. B squared then, if I subtract the 4, will be 21. So my missing side is square root of 21. And like we talked about, this is the same exact math you would do for both of those, right? So square root 21, square root 21, yeah, side, side, side. Okay? But if you take a look at what you were given, you only had to start with that. So this is called the hypotenuse leg theorem, or just HL.
Is that on our theorem sheet?
I believe so. When we go back and review for your test, we're going to fill out the rest of that sheet.
Really?
So, yeah. So you don't need to do it right now if you don't want to, but we will spend the time to do it later, though. Oh, bummer. So hypotenuse leg theorem basically just says this. If the hypotenuse and one leg of a right triangle are congruent to a hypotenuse and one leg of another right triangle, the triangles are congruent. Yeah, it's a little bit of a lot of writing, but not terrible. And it's really kind of a simple concept, though, right? If you match a leg and a leg, a hypotenuse and a hypotenuse, two triangles are congruent. Okay? So when we do proofs with this, you might use side, 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 or you might only have to do HL, depending on if the triangles are right triangles or if they are some other kind. Okay? So that's kind of where we're going to be heading with this, is taking a look at what we're going to need to use depending on what we've got set up. Okay, and can we match everything that needs to be so that we can do that? Question? Yes? Yeah, that's fine. Okay, so let's give this thing a try. We'll do a proof. So let's say, and I'll draw the picture here in just a minute. So the given information we're going to use is PQ is congruent to RS, and angle Q and angle R. I'm sorry, that should be S. Are right angles. Okay, and here's what your picture looks like that goes with it here. Okay, so it's just that as your picture, and you want to prove that triangle PRQ is congruent to triangle RPS. All right, so let's see if we can do that. Should be a pretty short proof. And it's going to be kind of the same setup, or the same like series of steps as we did when we were doing side angle side. So first you get your givens down, then you try to match up all the little corresponding parts that you need, and then you use the side, side, side. Or HL, depending. All right, so number 1, PQ congruent to RS. Oops, and also Q and S are right angles. Ran out of space. So that's all you're given. All right, so I'm going to try and squeeze in step 2 right here because I need 4 steps to do this thing, so just bear with me there. Before we go any further, what should I be doing with this thing? I should probably be drawing things on my picture so I can kind of see what's going on. So we already said that PQ is congruent to RS, and we said that Q and S are right angles. So we've got that much information at the start of this thing. So can you guys see the path with this one based on that? What am I going to end up using to prove that these two triangles are congruent? Am I going to use a side, side, side? Or am I going to use a side angle side? Or am I going to use hypotenuse leg? Yeah? I can't do a side angle side. If I did side angle side, I'd have to know that this side PS was congruent to this side QR, because the angle wouldn't be included in that. So, anybody else? Yeah? It's going to be a hypotenuse leg. Okay? Why is somebody else? Why is it going to be hypotenuse leg? Yeah.
They share a hypotenuse and they have two. Each one has a leg.
Exactly. All right. The hypotenuse they share, and they each have a leg. That's the same. And we know that they're right triangles, right? Remember, hypotenuse leg only works in a right triangle, and these are definitely right triangles too. So, yeah. So that's going to be kind of the goal. And again, we need to make sure that we match up all the things that we need to make that work. Okay? So, first of all, for hypotenuse leg to work, I need to have right triangles. So I actually have to say that in my proof. This is a right triangle, this is a right triangle. Okay? You do, yeah. But it's not hard to do. Triangle PQR and triangle RSP. Well, let's see. If I'm doing PQR, I should do, RSP. Are right triangles. Now, how do I know that they're right triangles? Definition of a right triangle. The definition of a right triangle is a triangle that has a right angle. And you've already said that Q and S are right angles, so we know they're right triangles then. Yes, sir?
What's the second triangle you put? It's P, Q, R, and...
RSP. Okay, so I've established that I have right triangles. That's one thing that I need. I've already stated that I have PQ and RS congruent. Those are two legs that are congruent. Okay, I've got that. What's the only other thing that I need to show these two triangles are congruent? They're right triangles and they have legs congruent. What else do I need to do hypotenuse leg? It's okay, go ahead. We need to show that they have the same hypotenuse. Right. Okay, so that would be my next step. Okay, and how would I write that? Yep. Sure, yep. You could do PR if you don't like RP, sure. Okay, we got to use that they're congruent to themselves kind of property there. So this segment in the middle is now matched with itself. What property is that says anything is congruent to itself? Somebody different this time? Other than those guys in the back? Yeah. That's reflexive, right. So reflexive property. Okay, so I've got the three things that I need. I've shown that they're right triangles. I've shown that their legs are the same. I've shown that their hypotenuses are the same. Now I'm done. Now I can just jump right to the end. I've got everything I need. So triangle PRQ is congruent to triangle RPS using what? HL. You can just write HL. You don't have to write out theorem if you don't want to, but either way. And done. QED, what we were trying to prove. QED, yeah. Oh, nope.
What does it stand for?
Quad iterat demonstratium.
Wow.
Or you can do the little square too. That means the same thing. Yeah. All right. I want to try one more proof with you guys, and then we can be done. Okay? Short lesson. Yeah.
Well, I mean,
Yeah. You're gonna have a lot of time. Yeah.
is it going to be like longer than long?
It's not going to be terribly long.
I know you will. I'm scared.
All right. I like to call this the bow tie problem. All right, so here's what we're given. P is this point in the middle here. Oh, right. So P is the midpoint of NR and QM. And then also NM is congruent to QR. Okay? That's all your given information. And we want to prove... Write this down, please. I'm not doing this for me. We're going to prove that triangle MNP is congruent to triangle QRP. All right. You guys see how this one's going to work? See, it's always good to see if you can kind of like reason your way through it before you actually start, because then you have a little bit of a roadmap in your head. So, hold on. Shh. So, if P is the midpoint of NR and QM, what does that tell us? What is a midpoint? It's halfway between. And if it's halfway between, then you have two segments that end up being congruent as a result of that, right? And for both of those, I'll have two congruent segments. NP should be congruent to PR, and MP should be congruent to PQ. Okay? So you're going to have two sets of congruent segments from that, and then you also know that NM is congruent to QR. So then wouldn't you have three sets? And if you have three sets of congruent sides and two triangles, what can you use to prove they're congruent? Don't overthink it. Yeah? Side, 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 right? So I'm setting up a side, side, side problem here. Okay? What? That's what we're going to do down here. We're going to show why it's that. You actually have to do the proof. Yeah. I'll talk about that later. because we're doing this right now. Okay, so again, before I move ahead, I'm going to mark my picture up with what I know. I said these two segments were congruent, so we can start with that. And then remember we talked about if we have midpoints, we know that we have these congruent segments, okay? So since P is the midpoint of, take a look at the picture, since P is the midpoint of NR, what does that tell us? Yes?
That NP is congruent to PR.
Good job.
Thanks, Stephen.
And then also, because P is the midpoint of QM, what does that tell us? Not exactly. Okay? We can leave that as the same step because the reason is the same for both of those two things, right? What's the reason why those are congruent? What did we just use? Yeah. You got it. Midpoint. Okay. Yes.
Is there a special symbol for midpoint?
Nope.
Oh, there was.
Okay. So, now based on what I just did in step 2, I proved that NP was congruent to PR. I proved that MP is congruent to PQ. Okay, and there we go. We got side, side, side ready to roll. I can finish this thing in step 3. Triangle MNP is congruent to triangle QRP. Side, side, side. Okay, so, yeah, my question to you is this hard? No. Shh. Is this hard? No. Does this take some effort? Yes. And there we have it. Okay? That's where people, if you're going to struggle with this, that's where you're going to struggle. I guarantee it. It's the effort. It's not just, oh man, it's too hard. Guarantee it. Okay? Do the work. It'll be fine. Okay?